Thank you everyone for coming. It is it's such a pleasure to introduce Chris. For all of us New Yorkers, this goes back quite a while. I've known Chris and his brother Bill from before they were shop architects, and we were all working as ambitious young architects in a shared loft on Mercer Street, located over a cigar factory, wind blowing through the windows, toilet was shared by everyone, and animals roamed free in the space, and these were not the normal animals, these were roaches, rats, mice, things. It was more like the non-human space than the human space where we started, but it was also a space of incredible inspiration, collaboration, where we all worked together on competitions, and one of those moments where you really learn to be an architect because you are together with so many colleagues that are all starting with you at the same time. Chris came through architecture in a little bit of a roundabout way via Dickinson College, where he received a liberal arts degree, explains a lot. And after a break working for his uncle, John Abbott, I really dug deep, have you noticed? John Abbott, who's an interior designer, he then realized that his heart really was in architecture and went together with his brother Bill, identical twins, to Columbia. That's where I was in a postgrad. They were there and they met the other shop partners, Craig Pasquarelli and Corey Sharples. Interesting team, the four of them, all with a different interest and very equal in the sense they all had real-life experiences before they came to Columbia. They all worked in some level of practice, but coming in with business, technical, detail-oriented, so interesting group of partners of four. And it was actually interesting to look into that because you know all how difficult it is to work with partners and how hard it is to keep them for a long time. And this explains also a lot about them because it's one of the few successful partnerships we've seen where people still are working together in a really inspirational way. Both Bill and Chris have taught and lectured also a lot. They share their knowledge freely, I should say, including Cornell University, Yale University, Columbia, and Parsons School of Design. And I have dragged them to Penn as much as I could for reviews and lectures. In addition to work at shop, they also have Assembly OSM, an off-site manufacturing-based company that transforms the way buildings are designed and delivered. And this is very much part of the three main considerations that they have as the essence of their office, which are including affordability, so making buildings for all. I often said, beauty does not have to be expensive. This is a really weird battle you have to fight as an architect. People have this idea here in the US that beautiful is expensive. It's going to be your most important task to explain that beauty is for everyone, not necessarily expensive. So everyone should have beauty and affordable housing. The other point they fight for is climate responsibility. Buildings, as we know, have the highest carbon footprint, so this also gives us agency as architects to kind of learn to mitigate that because we actually can reduce the carbon footprint essentially a lot. And then labor equity, I love that one. There's so many people who are endangered, underpaid, and underappreciated in the supply chain. We architects know all about that. Three beautiful points, I thought. Shop Architects is known for integrating design and excellence with cutting-edge technology and sustainable solutions. They've received very many awards for this, including the Medal of Honor in 2025 by the American Institute of Architects in New York, the 2022 American Prize for Architecture, and the Smithsonian National Design Award, and that's just three of very many other awards. But more importantly, I like to go into the work, so recent projects such as the Atlassian headquarters in Sydney, Australia, as well as the US Embassy in Milan and Bangkok, and there's a few other ones, I saw one in Honduras, and the Barclays Center in New York, and of course 111 West 57th Street. I had a friend who was the broker there, so I was spying on that building quite a bit and went to the opening. But all these buildings have given them the opportunity to test out ideas that bring out beauty, culture, and the significance of how we experience cities and buildings. They state, developing and applying technologies is in interest of safeguarding the joyful human elements of design and improving the process of collaboration in specific, authentic placemaking. So I think that's a really beautiful point. So it's not technology for technology's sake. Yes, it is to make a better building, a more beautiful building, but very much to also create more joy and fun in architecture and in the environment. He also advocates for an architecture that is collaborative, regenerative, and future-focused. This is very clear for their work and for example, Uber in San Francisco, the headquarters, Atlassian and the YouTube headquarters, a few big clients, where the design concept intended on helping people reconnect with the idea of the office, especially after the pandemic, and then basically championing this practice that merges design with advanced technologies, sustainable materials, ethical sourcing, and transformative construction methods, which is very much also part of their OSM, off-site manufacturing idea, which means prefabrication, making for much more precise elements, construction elements, but also in a very precise fit. So there is a whole other level that gets much closer to industrial design that will make buildings very different and, in their case, also incredibly beautiful and interesting. So please join me in welcoming Chris for this lecture, Responsive Futures, Technology, Space, and the Human Experience. Thank you, Chris.
Gosh, Winka said it all, so I'm done. I'll see you. No, that was great. Actually, I never really get that kind of introduction. It was in a way, it's sort of, I like to begin by sort of summarizing what I'm going to talk about in the next 50 or 60 minutes is a little about the work that we've done, but more importantly, some of the challenges that we're facing in our industry. And sort of Winka sort of touched on some of that. And it's exciting to be here at SCI-Arc. I think the last time I was here was almost 20 years ago, and I think Greg was here maybe 10 years ago. So I think it's like we come every decade. But one thing that I always remember from my first time here is how involved the student body here is in the act of physically making and prototyping. And means and methods, and that's something that I think we at SHOP believe is incredibly critical, more so now than ever before. So jumping into this, this is a slide that we show quite a bit. We all have taught. We believe it's very important that there needs to be a stronger bridge between the academy, the ideation, the research, the outside thinking, and connecting that more with the profession, with the practice. So it's sort of both and as we say, beauty and technology aren't mutually exclusive. They really go hand in hand. And if you look back in time, like it's exactly what Gropius was talking about when he founded the Bauhaus. Now, we're a general practice. We don't necessarily specialize in one type of building typology. And I think more so today than ever before, it's really important for architects to really, look beyond just trying to specialize in one particular building type. It just makes good economic sense in terms of having a diverse portfolio. But we sort of learned we were very lucky with our very first commissions that they tended to be public in nature. And what we learned from this is that when you create really meaningful, great public space, it really supports, in a very resilient way, the architecture. We always get the tourists in New York, but it's the community that keeps coming back with families, the kids, the dogs, that really create that vibrant economy. And so what we learned is that there's a number of different key elements that you need, obviously, making sure you have the infrastructure in place, but simple things like scale, creating buildings that are scaled for people, rich in materiality, bringing in nature, daylight. All these elements really come back to what Vink was mentioning, creating that sense of joy, that sense of beauty, that you feel like you're part of something special. So we were very lucky that our first project happened to be a 5-acre park, but this is what the site looked like. And the village of Greenport, one of the last active fishing villages on Long Island, was really suffering. And I remember when we won this project, a lot of the villagers were like, we don't need a park, we need more commercial space. All the commercial space on Front Street was vacant, and we're like, really, you need more commercial space? But what was really interesting was how this park completely transformed the community, the economy of Greenport. Not only did it create the sense of a heart where people in the village could gather, but people from outside of Greenport started to visit. It's funny, when we won this commission, to tell your parents after 7 years of higher education, the first project you do is a carousel house. But it's that carousel house where they charge, $1 a ride that really helps support the livelihood of this park and maintain it. And so we sort of, had the opportunity, and next big commission, we were able to supersize that concept, where we won a project where we got to master plan a 2-mile esplanade along the East River. And again, trying to reconnect the communities. There were 7 communities, neighborhoods along this stretch, but this is what they had to deal with. So really looking at how we can make that connection to this incredible waterfront, bringing more natural systems, more amenities, looking at how these elements really start to create a sense of community. And it's doing very well, but just up the river was another sort of distressed property. This is the post-industrial Domino Sugar refinery site that we were invited to develop a master plan. The Lewentises, David and Jed, are known for their huge saving of Dumbo in Brooklyn, and they kept moving north, and they purchased this site. And it's about 3.5 million square feet of mixed use. And I'm not going to go into the massing first, but the main point is, what was beautiful about working with this client was that they invested in the park first. Field operations were the landscape architects of this park. Typically with developers, they don't invest in things up front that aren't going to hit their bottom line right away. But we were able to convince Jed and David that if you really wanted to create a sense of place, it had to feel that way day one. And what was a blessing in disguise is when this park was done, COVID happened. And so it wasn't just a park for the 3.5 million square feet of mixed use. It was actually a park for Williamsburg. And so what was exciting was to see how, it transformed and really started to become a new anchor, a new community in this part of Brooklyn. We did the first ground up building, 50% affordable. And again, thinking about how you develop a project like this, we could have done all the buildings, but like with lots of these kinds of projects, you really want to have many voices. So it's something that was very exciting. Cook Fox did the building on the left. Annabelle Zildorf's building is actually complete. Powell did the office complex in the old factory building, and Rex is going to be doing the last building on the site. So it's really exciting to see how some of these projects have evolved really out of a simple concept of creating really meaningful public realm experience. The same is true for what we did at the Barclays Arena. This is basically what the site looked like. It was a transit hub for actually there's a whole bunch of different 7 different subways, several bus lines that all converge here. But really, it's an arena. It happens to be arena, but it's really more about that civic gesture, that sense of of welcome when you come out of these subways into a space like this. And it's almost become, the new heart of Brooklyn, where, either you're going there for a game or it could be for a demonstration. And so it's sort of, as it's noted here in this article, it's a new town square. So really thinking about how we as architects don't necessarily start with the actual building first, but actually think about what is that public realm experience that's going to support that architecture. This is a site of the old Hudson's department store in downtown Detroit. This, at one time, was the center of everything that was happening in downtown Detroit. It was torn down in '98, 26 years later, after Dan Gilbert came back and bought up basically 100 of the historic buildings there. We worked with him over a decade to create this new mixed use, what I would call radical mixed use hub that includes a new headquarters for GM, which moved in a couple weeks ago, and many different amenities to support not only new office space, new residential and hotel, but event space as well, to really talk about this idea of a new renaissance for Detroit. We also happen to be doing a lot about transforming, the skyline of New York. Some people would say, what's wrong with just having the Empire State Building, Chrysler? We can understand that. But it comes back to what Winka was saying, is when you do this, you have to think about not only the people who are going to live in these buildings, but it's also for the people who live around these buildings, the people in the city, when they look at it. Is it a gift? Is it an architecture that really draws you in? So from American Copper to 111 57th Street to the Brooklyn Tower. And two of these projects are actually grounded in landmarks. And a lot of the DNA of these buildings, and I'll talk a little about this later in terms of materials and fabrication, really informed the overall design and actually was a huge impact in how we got approval from landmarks. But we've even done some small projects. This is Site Santa Fe in New Mexico that was in an old beer distributed warehouse. And, transforming that into a new Kunsthal was a great experience. So, whether we're working at a large scale or small scale, it's still the same mission. How do you transform these underutilized spaces into something meaningful? This is a project that we started just after 9/11. It was a site 5 clicks south of the DMZ in South Korea. This was an actual military training ground that turned into a new art park. And we did one of the main gallery buildings there, the Hangil Book House. And so, again, looking at how we transform some of these types of spaces that, have certain types of scars or certain types of memories, and really creating this sort of new lease on life. This project just opened last Thursday. We started in 2003. That's when we got the commission. Talk about taking a long time. This is the new academic building for the Fashion Institute of Technology. And what's so great about this building is just the level, the diversity of different sort of crafts and skills and departments here. This is the digital weaving lab, the perfume lab, this is the toy lab. This is actually a project that Shannon worked on very early on. There's actually Shannon there. Bill's pretending that's my twin brother. He's pretending to do something. So really looking, and it's so exciting to see how these spaces are now taking on a life of their own. And as Winka mentioned, we are doing 5 projects with the U.S. State Department. This is the new consulate that's in construction in Milan. And this is the new consulate that we're doing in Bangkok, which is also in construction. With all these buildings, they're big buildings, and, how do you scale buildings? How do you create that human scale intimacy? And we really see that it's through the materials. How do we craft these materials? Are the traditional materials like stone, wood, metals, and even new materials like bio-based, materials like 3D printed bamboo or carbon fiber. And this is where, that relationship between leveraging technology and building those relationships with the fabricators. So in a way, a lot of the DNA that, you experience here in terms of prototyping is something that we take very seriously at Shop. We have our own full-scale prototyping lab in Stagg Street in Brooklyn. We do full-scale mock-ups, and what's really important about these is, you go out there to fabricators and you say, this is what we like to do, and they're like, yeah, you want us, we have to figure this out, and we're like, no, actually, we did a prototype. This is how we would approach it. And so whether it's, working in CLT, this is the National Veterans Resource Center at Syracuse, or to the way we work the terracotta for 111 or the stone for the Brooklyn Tower, or the Porterhouse project from early 2000s. But, a lot of the inspiration, a lot of the research really comes out of these small prototyping projects. We didn't realize how important PS1 was when we finished it in 2000. It actually took us several decades to really realize how this really was the beginning of our thinking about prototyping. But, when we got this commission, Alana Heist was the director of PS1, a contemporary art museum in Queens, and she was always, she had gone out with Joey Ramone. She was at CBGB's all the time, and so she was always out there. And she says, the summer's hot in New York, and not everybody can get to the beach. Can we bring the beach to Queens? So the whole idea for our Dunescape project was really understanding that relationship between the body and the activities that you associate with the beach. And so we developed this model, and at this time we were in MicroStation, and developed this model based on those sections. So the way you read this is that the blue and red are actually AB sectional relationships, and it'll become much clearer in the next series of slides. But the fact that we were working directly from a model, so we were able to extract information from that model and print the drawings at scale. So it's 20 feet in length, and you could go 3 feet on the printer, so that's stacked 15 feet. And you quite literally built PS1 on top of the drawings. So the drawings weren't a representation of the project. They were the actual instructions for how you would make that. And that becomes important later on in the conversation. But what was really exciting was people could see how it was going together. So that became part of the spectacle for this project. And just the beauty of the material is cedar, 2x2s, and we had misters. So it would create this incredible sensory effect as the wood became, had this incredible scent. What was also really interesting is the drawings that actually built the full scale were the same drawings that built the model. And we built a model after we had done the project, and the model now is in the collection of the Museum of Modern Art. So, as I was saying, prototyping has always been a very big part of our office. And these are two projects that we actually did within 1 year of each other. The first one is for Art Basel in Miami, and the second one it was for the furniture fair in Milan. And these are some of the companies that we worked with here, Branch Technologies, Oak Ridge National Lab, NBK, the terracotta fabricator in Germany. And so this is the example of the terracotta project we did in Milan. And we're working in the computer. In this case, we're working with Rhino and Grasshopper. With the Miami project, we were working in CATIA. So understanding how do we use these modeling softwares, and how do we share and communicate with the fabricators, understanding what the machines the fabricators have, what are they capable of using, how we start creating these files that are direct to fabrication. And what was interesting about this project, it was the same extrusion, but then using CNC technology, each piece was cut a bit differently. So what it became was quite actually a three-dimensional puzzle and coming together. And so you're thinking about how do you apply these ideas to a full-scale project? And I'll get to that in a second. But it, again, comes back to this idea of creating beauty and joy and wanting to just go up and touch it. In this case, working on a project that actually had to go up in a very short period of time, and then after 5 days had to be disassembled. So here, thinking about designing something for disassembly. So the benches were actually produced out of 3D printed bamboo by Oak Ridge National Lab, and Branch did the carbon fiber. And this is a study, these are the kukas that Branch used, and they had names for each of the kukas. But you can see how each kuka is split up, understanding logistics. The pieces had to be sized so that 2 people could pick them up, so they weren't overscaled. But what was really incredible is how quickly it went together. To us, it's always in the prep. It's like cooking. If you got the prep right, the meal goes together smoothly. If you have to go back to the refrigerator, something's burning on the stove. And so it's really understanding, running these virtual models, checking out, making sure everything is in line before you press go. So what was really beautiful about this project is after 5 days, it got disassembled and then reassembled in the Arts District and was up for 2 years. And then Anna Dyson, professor at Yale and founder of Center for Ecosystems Architecture, borrowed it and brought it over to the University of Nairobi for a UN event on bio-based materials. So that's where it currently resides. So the whole idea of thinking about an architecture where you're designing something that can actually either be disassembled or upgraded over time is probably one of the most resilient things you could think about when you think about the environment. But this really comes to the crux of the conversation, is we really do need to rethink how we work. We have to think about how we innovate our process, and why now? Well, it's pretty obvious. We've got some huge problems. Obviously with the climate challenges that we're facing, and you all experience that here, and the impact of these events on the community. How do you even begin to rebuild this back, especially in the context that we're all dealing with right now? And on top of that, we're having more people living in our cities, but we do not have the housing to support it. We're actually seeing a lot of flatlining, and it has a lot to do with the fact that the way that we build is not addressing these needs in a timely way. It's becoming more and more expensive. And as some of you might be aware, we're in a critical mayor's race. The elections are next week. And the big topic is affordability. And as Winka mentioned, the amount of embodied carbon in our built-in environment is quite extreme. And we are, as prices go up, people are always looking for cheaper ways of getting those materials. And it happens that typically, you run into this issue of forced labor. And typically there's a relationship between embodied carbon and forced labor. When there's high forced labor, there tends to be a lot of high carbon as well. And one of the problems in order to deal with this is really we have a very unresilient supply chain. You saw what happened during COVID. A ship gets stuck in the Suez Canal and suddenly you have a backlog. So, and as an architect, we really do not have a very good sense of where our materials are coming from. So we really have to think about how we innovate the process. This is a image that was produced back in 2017 by McKinsey, sort of outlining where construction was in terms of innovation, and just below farming and hunting. So the hunter-gatherers are more innovative than the AC industry. But where we've seen a huge jump in innovation is in advanced manufacturing. And so if you ever come to shop, one of the things you'll see is, besides a lot of architecture models, is a lot of airplanes and cars and boats, because a lot of the inspiration that we get is actually from these other industries. And how do we leverage what they're doing and draw that into our own space. And it's not like the tools aren't there. I mean, we proved it out. You know, in this case, we modeled out all the MEP systems for American Copper. So the thing is, how do we begin to start innovating and accelerating this kind of thinking? And what's really exciting is a lot of the technology that's been developed is actually coming out of gaming and out of, companies like Dassault Systems that basically develop software for advanced manufacturing, for the design and fabrication of cars and airplanes and boats. And so working with Unity and Epic and NVIDIA, really leveraging these relationships and seeing how we can bring these tools, these model-based tools, into our space. It really starts with data visualization, because we operate in a highly complex environment, and showing plans and renderings is not the best way to manage complexity. So whether you're dealing with a client or a community board, being able to go out on site and say, well, this is what this building might look like, or pulling them into a fully immersive 360 space and running simulations. And what's amazing, it beats putting a headset on, because people in the room and they're actually talking about what they're seeing, and they're solving problems in real time. The other thing is being able to bring these tools out into the job site so that you can really forecast and help manage risk. And what we're finding with this process is it promotes more collaboration. We operate in a highly disaggregated, highly siloed, highly litigious environment. And so everybody's trying to protect themselves from being sued. But what we found with these tools is that when everybody can see everything, they tend to not only try and solve their own problems, but they try to help others solve their problems. But what's also exciting is as you start working with these types of models, it's an organic process. It's more inputs as you move from concept through schematic DD all the way to post-occupancy. These models are taking on more and more data. So at the end, you have a live as-built of what got built, as what we hear in the industry is the digital twin. But so the challenge is, how do we move beyond the conventional model? There's so much inefficiency on the job site. Reworking, I don't think people still use light tables, but this is how MEP drawings used to be coordinated, putting the drawings on the light table to see if there's any clashes. Obviously, we have BIM. But you still have job site safety issues. You still have change orders and reworking, incredible amount of waste. And then this is the thing that really, people who live around a job site just accept that this is the status quo. I just have to put up with it for 3 years. Concrete trucks, noise, safety issues, particulates. Why do we have to put up with this? And so, when you start bringing this up in a community board meeting, they're like, yeah, why do we have to put up with this? So looking at how we can begin to look at new models of delivery, which not only start to address these challenges, but also open up opportunities as architects to really push really innovative thinking and design. So, for us, the first time we did this really at scale is at 2009 when we got the commission to do the Barclays Arena. And here, this is a CATIA model of all the weathering steel panels. There's 12,000 panels on this building. They're all different. We actually didn't tell the contractor and the fabricator in the beginning that they were all different. We said maybe there's 10 different ones. But as we started working this process, this is an unfold that shows the schedule of all those panels. There's 940 mega panels. They're also all different too. But what's interesting about these is that they're the size of a tractor trailer truck. So when you think about volumetric modular, thinking about doing buildings at this kind of scale. So how do you coordinate that? How do you begin to have these conversations with the fabricator? And so this comes back to the big crux of the problem. Architects in this country, unlike other countries like Germany and Japan, for example, the architects are quite involved in the means and methods. Here in the United States, we are not supposed to be, as architects, involved in means and methods because of the issue managing risk. We gave that up in the 70s. But what's interesting is when you start working this way, this is the best way to manage risk because you can see when you're going to run into a problem. Here, this is looking at how to find the right coil width to optimize material so we don't have much waste. If you look at that little box with all the numbers, that's the data the fabricator gave us in terms of understanding how they wanted these files given to them so that they could begin the fabrication. So through that process, our team, John Cerrone, my partner, and Brian Sweeney wrote code so they could automate the shop drawing tickets. So instead of having a whole battery of people doing shop tickets for 12,000 panels, they were able to automate it based on feedback from the fabricator. And then setting up a tracking process where as the panels are getting weathered or broken, or cut, water jet cut, you knew exactly where they were in the process. And it was uploaded to a web-based viewer. So it wasn't just the architect who could see where this was, or the fabricator or the builder, but even the owner, Bob Sand at Far City, he could see where the project was. So when you start talking about payment requisitions, you can actually see what is on the building or what is in the factory. And then it was interesting, by the time we got through this whole process and we told the fabricator that every piece was different, they're like, no problem, we've got a system in place. So it's really this whole feedback process. But what's exciting is that at the end of the day, you have a model that is the single source of all the product data for this envelope. And even with Daktronics, I'm working with them and understanding how to put the signage board in there. But one thing that we realize is that there's a lot of on-site work being done. And one of the challenges is making sure that all the hanging clips are in the right place. So we did a digital scan of the steel infrastructure, and we found about 16% of those hanging clips were out of alignment. And so John's up there with his iPad. The foreman was like just pulling his hair out. But the young iron workers were like, show us where we have to reposition these hanging clips. And what was great is every mega panel went up right the first time. Now I got to tell you, if a panel had shown up and it didn't fit, they would have had to put it down on the sidewalk. And before you know, you have another truck showing up with another mega panel. And suddenly you have a train wreck. And all I can say is this building was from start to finish 3 years, 2 months. And I guarantee you, we would not have been able to open it up to the HJZ's concert if we hadn't been using this sort of model-based delivery process. With the same client, they also own the Nassau Coliseum. And here's the case, instead of ripping this whole building down, we gave it a new lease on life. And so here, again, using the same process, the same innovative process, looking at how we use a model-based delivery, scanning the existing building, making sure those mega systems work. What was the difference between this and Barclays is they had a huge parking lot. So they could actually take all the pieces and put it together right next to the building and then lift it up into place. And so it was just amazing. 1 week you go by this painted black mausoleum, the next day, next week you start to see this amazing building. So it was exciting to test these two projects out within close vicinity of our office. But at the same time, we were working on this project in Gaborone, Botswana, a new innovation hub which we had won. And we wanted to see if we could test the same process on this project and developing a rain screen system. And this is where it gets really interesting, is when you start working with some of these aerospace softwares, is that again, the instructions are part of the model. The whole idea that it's not necessarily a representation of the building, it's the actual instructions. And what's amazing is you can take it all the way down to the screw. And that's what we need to do. We need to take into consideration every element of that building. But it ends up being a very heavy model. So the way it's managed is through a lightweight wire frame. So you see all these different colors. Each one of those lines has material attributes programmed into it. So when you bend 3/16 inch steel, the bending radius is actually the radius of what you would get with 3/16 inch steel, because this is what Dassault's has programmed their software to do. And if you start moving these lines, it's parametric. It starts to adjust the adjacent range screen assemblies next to it. When we first did this back in 2003, you literally had to go back into the model, this is before Grasshopper, with Rhino and actually physically do it. And here you have this sort of very pliant process. What's also great is you can see who's working on it, how much time they've done. So this whole idea of tracking, just like I was showing with Barclays, and the 3D scanning of the site. But what was amazing was the level of precision and quality that we were able to achieve in Botswana. This is sort of our IKEA instruction set. So the thing that we did differently here from Bots is we worked with a fabricator in Cape Town. Instead of building sub-assemblies and then shipping the air all the way to Botswana, what they did was they produced all the pieces and cataloged them. And they were actually assembled in the parking garage of the new building and then placed on the building. So what was amazing is the level of quality that we were able to achieve for an incredible price. And so we realized, we could do this all over the world. It's about finding that right fabricator to support that process. And it's that feedback loop that's critical to this. So what we learned is, with unitized facade systems, this is actually very geared towards manufacturing. So the question is, how could we take that concept all the way to the doorknob? The whole building is done that way. And the whole idea here is moving towards this idea where we're all collaborating around that model. Now, that doesn't mean that we're going to singularity on the tools. Oh, everybody has to use CATIA. No, TT, Thornton Thomas said he uses Tekla. We still have to use Revit because we have to print out drawings for the building department. But the fact is, with interoperability, you're able to consume this information, and actually you can go from CATIA into Revit and back into CATIA again. That wasn't something you could do, 10 years ago, but these are the kinds of things that are able to be done now. But what's great is that model is a live viewer where everybody can get around it, including the owner, the client, and if you want, even the bank. So this brings us to the next challenge is, material science. I talked a lot about software and digitization, but really the future in our industry is all about material science. I think it's Jeff Kipnis said that one time when we were at Columbia. He says, yeah, computers, yeah, but it's materials. And we are dealing with some huge challenges. Obviously, if you look at the UN Materials Report, which Anna Dyson helped draft a couple years ago, concrete is, at the top of the list in terms of embodied carbon. And, it's not like we're going to shut off the concrete and start working, do everything in mass timber. But what we're finding is, can we look at hybrid systems more as a way of really using materials in a very efficient way? And so with our project, the new headquarters for Atlassian in Sydney, Australia, it's actually 3 primary material systems we're using here. A steel exoskeleton for the skin of the building, a concrete core, and every 4th floor, a concrete and steel deck. And on each one of those decks is a 3-story mass timber village. So we're putting basically the natural materials where the people are, but cutting down on the amount of concrete and steel. So it's not like it's going to go away, but it's really looking at how we can optimize and work with materials in a very efficient way. And so every village gets its own little park. Like Uber, the facade is designed to open up. This is a mid-door space, so it's actually not conditioned with MEP systems. It's actually conditioned by the outside air. And then that's the terraced roof. So this is currently in construction. It's going to be a couple more years before it's done. And this is the other thing is, again, coming back to that whole academy, really embracing some of the research and the collaborations. We're working with University of Maine. They're really focused on additive manufacturing using bio-based material systems. Oak Ridge National Lab, who's very interested in getting the AEC space, do a lot of work DoD, but they see that there's a real opportunity to leverage a lot of these approaches with advanced manufacturing. Center for Ecosystems and Architecture, Anna Dyson's program at Yale is focused on how to use bio-waste, like coconut core, for example, to turn these into building materials. And this ties in a lot to the whole idea of ethical sourcing, where you're basically bringing the farmers together, almost this, bringing back the whole concept of a co-op, where the farmers actually have some agency and control. And so this is something that is a primary goal with her program. And then on the far end, working with Grace Farms Design for Freedom on ethical sourcing and some of the software that's helping us support more transparent, more resilient supply chain. So here's Oak Ridge National Lab in UMaine. UMaine's working with Wood PLA as their primary. And why is this interesting? Now, we're seeing a lot with additive manufacturing printing homes, which is exciting. But doing single-family homes or two-story homes isn't going to solve the housing crisis, especially when we talk about our cities. So when you start thinking about additive manufacturing, it ties into how do we manage complexity and part count. So here you see a floor cassette, hundreds of pieces, lots of screws. And then on the right, you see one additive manufactured 3D printed floor cassette, which happens to also include not only the structure, but the ducts for supplying the fresh and exhaust air. And what's exciting is you see this kind of innovation happen in aerospace. This is SpaceX's versioning over several years, showing, on the left, Raptor 1, the level of complexity. And then looking at Raptor 3, 3D printing and reducing that level of complexity in that part count. Now, critical to all this is understanding material performance. One of the challenges that we face is dealing with the building code. One of the biggest challenges with doing additive manufacturing is the binders. They tend to be highly flammable. So this is a conversation we're having with Oak Ridge and UMaine, is we need to come up with a binder that is not going to have that kind of problem. And once that gets cracked, that's going to just open up the whole possibility of what we can do with some of these materials. And here's a prototype. This is from several years ago. But what's amazing, in a very short period of time, you see the level of precision that evolves as these technologies and techniques innovate. So when we start talking about the whole idea of OSM, off-site manufacturing, there's many ways to look at it. There's volumetric modular, there's prefab, there's hybridization of the two. So it's not like one size fits all. You really have to understand how you apply that model to the particular problem. But also, how can that approach to OSM and DFMA help support more of a adoption of natural systems, bio-based systems within the material supply chain? Again, this comes back to how the aerospace industry operates. Now, we heard all the horrible things that Boeing has done, and whether it's not holding back information and putting pilots in a bad position, problems with supply chains. If you really study the history of this company, what built this company was the culture of the engineer and the fabricator on the shop floor. And what happened over the last several decades is they got usurped by the shareholder. The executives placed a priority on the share price and took away all the feedback, all the knowledge and all the input from the engineers saying, hey, we got to slow down, we got to think about what the impact of some of these systems are. And so the simple answer is culture is everything. When you have an office, if you don't have a good culture, you're going to have a really, really big challenge. And you see what happens to a global company like this that had an incredible track record. And hopefully with the new CEO that we're going to start to see a turnaround there. But this is the model that we're also used to. Everything from your steel and concrete to the kitchen sink shows up at this site in the middle of your city. So imagine everything comes by a truck to a congested environment on a city street and has to get unloaded and put into this building. And then on top of that, you have a logistics stance. So what happens if something shows up late? So there's all these challenges when you start to realize that everything has to show up at the job site and then get assembled and put together. So looking at the aerospace and automotive model of this idea of a tiered system of sub-assemblies. Now the key to all this is how do you manage all this, through a digital process? And that's where the architect and the engineer come in. How do you manage all these logistics? How do you share this information with a fabricator? How do you pre-qualify your fabricators? So this is really where we have to start going with where our industry is. And we see some of the benefits in terms of efficiency, reduced waste, reduced energy. These all, and when I hear people say, oh, it's going to be cheaper, we like to say, no, it's going to be the same cost as conventional, but it's going to be in a shorter period of time. So your loans that you're paying, your financing charges, your interest rates, you're collapsing them in a shorter time period. So your building goes up, it starts renting, you start paying off the debt. So these are the kinds of things. This is where the savings is. And as you keep doing this, you get more and more and more efficient. Henry Kaiser proved that out with the Liberty ships in World War II. It usually took about 2 years to build a merchant ship. And the submarines were sinking them quicker than they could build them. And Henry Kaiser said, hey, we got to rethink how we put these ships together. And basically building these ships like they build them today in sections. But it's all about how you lay out all those materials and manage logistics in a very efficient way. So this is a studio apartment. And again, coming back to that image of the aircraft, all the information is captured in this single source model. And then you deploy all those components out to the different fabricators. Now, it's key that you pre-qualify your fabricators. You want to make sure that they do a prototype to prove that they are able to generate the quality that you're looking for. But again, it's a model-based delivery process. And here you see, this is alpha. So when assembly started, they were testing out these ideas at a small scale. So this is a 1-bedroom. And what you see here, you usually don't see this with companies. They don't open and look under the hood and see how you do this. But you run the virtual model of the factory on one side. And you see, and this is software that exists where you can actually assign a certain number of people, a time frame, what is the system. And from that, you're able to understand how long you're able to take to pump out a mod. And if we look at like Henry Ford, who really modernized the concept of the assembly line, when they first did the first assembly line of the Model T, they were producing 6 cars a day. So think about that, going from 6 cars to thousands of cars in a day. And that happens because you constantly are innovating and getting feedback and you're getting smarter and smarter about it. So that picture where you saw all those people in that room putting that together, those were all architects and engineers. There was only one licensed electrician. And the reason for that is they're learning from that process. And then they're going back to the model and say, we could do this better if we did it this way. But what was amazing was the level of quality that we were able to achieve. Now, There's no sheetrock in this project. Because when you work with sheetrock, you got to tape it, you got to spackle it, you got to sand it, and then you get spackle it again, sand it, prime it, paint it. That's not a manufacturing process. That would screw up your whole assembly line. And so looking at systems like, pre-finished MDF, but for the walls or the floor cassettes, what's exciting about this is they're designed for disassembly. So if one of those walls gets damaged, you could replace it. Or if it starts out as an affordable housing unit, but the owner owns the property and they want to upgrade it, they could bring in new appliances. Or the idea is new technologies come online, like MEP systems. You can go in there and retrofit them. So the whole idea is, the traditional model with architecture, when you build a building, it starts to go in a state of decline. And right now, the average lifespan for a building in the United States is about 30, 40 years. And then it goes into and it gets torn down. Now, really beautiful buildings, that's not necessarily the case. We're in the Woolworth Tower, it's over 100 years old, and it's going through another love fest as people come in and say, oh my God, I want to work in this building. But think about this idea. The most resilient thing you can do is first make a beautiful building that everybody loves and doesn't want to tear down. But as new technology comes online, that building goes through an upgrade, and it keeps doing that. And you see that in the aerospace industry. Every 10 years, they strip the whole goddamn plane down right to its structure. Now, all those materials don't go into landfill. They get regenerated. Sometimes some of those seats go into another aircraft for, let's say, a low-budget aircraft. But the idea is that they're upcycled. And that's what we need to be doing. But the thing is, we have to think about design for disassembly. The other aspect is when you're working with these highly comprehensive digital twins, you can actually go into your apartment with your iPad and see what's behind those walls. So once you start putting sensors in, you can measure air quality, you could see how your space is metabolizing energy, but even more importantly, you can have a leak sensor in there, and you can know when you have a leak before it starts ruining your finishes. So this whole idea that, not only the owner and the design team have this level of transparency, but the homeowner could really start to understand what they've got. What is this asset? And how can this asset actually improve over time? This is sort of the second prototype that Assembly did, which was an 8-mod prototype that's in St. Felix in Brooklyn. The whole idea with off-site manufacturing is with volumetric is actually the facade comes with the building as well. So about 85 to 90% of the work is done in a factory. In this case, because we were in a landmark district, we actually had to lay the brick up. But you would never know that that was a modular building. This brings me to the last part of my talk. And, I think we all experience, especially those who live in cities, the impact of the pandemic on, or we realized through the pandemic how important it is to have nature in our lives. Anybody who had a balcony in New York had one up on their neighbor. I was lucky because my wife teaches at Yale. We have a mid-century modern in Orange, Connecticut, done by Marcel Breuer, and I learned so much being in that house, constantly looking out at nature while I'm on a Zoom, and saw how my stress levels went down. And so the whole concept is, how can we bring these natural systems into our urban centers? And I remember when we first met with Susan Wojcicki when she was CEO at YouTube, she said, I want everybody at YouTube, when they're at their desk, to be able to see a tree. I mean, you couldn't ask for a better, scope program for a project. Designing a building where wherever you are, you feel that connection with nature, with natural systems. And so this is another this project's in construction right now, and this is a hybrid structure, steel and mass timber project. But this whole idea of how you create a space, a series of office buildings where people are constantly moving through nature. And then when we did, it's another project that Shannon worked on. This is Uber's headquarters in Mission Bay. It happens now to be ChatGPT's space. But one of the things that we really pushed here when we were working with them, with Travis, was the whole idea that, 10 months out of the year, the weather is pretty darn nice. And so the idea is, how could we create a mid-door space that opens up and lets the whole vertical commons of this building breathe? So this is actually operating on a building monitoring system. Every day, those windows open up differently based on what is the temperature within the space. And so working with Atelier 10, understanding how that gets modeled, how the behavior of those airflows impacts these spaces. And what's really interesting is, you would think, oh my God, you're going to hear all that traffic. But a lot of people, once they sense that white noise, they feel that they're more connected to the city. So what we found is more people like working out in the mid-door space than working out at their desk. Putting natural materials where they need to be. There's no MEP systems in the vertical commons like Atlassian. It's all based on natural ventilation. And then we have a little glass bottom boat view here where you could walk by and literally look right up into the commons. So, when we were in COVID, everybody was concerned about air quality. It's funny, we needed a pandemic to start being concerned about indoor air quality. I mean, the indoor air quality is 4 times worse than what's outside. Now, granted, if you have a forest fire, that's a bit different. But the fact is, we spend 90% of our time indoors. And our mechanical systems really haven't evolved over the past 40 years. These centralized systems, if air's coming in 10 floors above, and by the time it gets to you, it's pretty goddamn stale. Pardon my French. So the thing is, how can people own their own air? So your air comes in through your apartment, it gets conditioned, and you have control over it. Now, one of the exciting things, and you see this with cars, you don't question, you have complete control over the air quality. And of course, obviously you have to change your filters. But in our case, we created this backpack system, has HEPA filtering and UV built into it. So you have this confidence and trust that what your air quality is good air quality. But the thing is, a lot of this air, when you shoot it through all these filtering systems, it sanitizes it. All that, the need for more natural systems in our built environment, it has an impact on our, I have a loss of word for the scientific term for this, but the biome it's like our yogurt, for air. We need that for our bodies. We need biodiversity. When we start sanitizing everything, closing our windows and relying on mechanical systems, we are really hurting ourselves in a very bad way. So one of the things that Anna Dyson, with a lot of her PhDs, have developed, and we've seen this a lot, with the Darlington system, the idea of green walls and stuff. There's no soil in this. But using plants, the roots of plants, to actually take the particulates out of the air. Now, through photosynthesis, plants love CO2. And when they go through photosynthesis, they give off oxygen. But one of the things that's really exciting, we helped supported them as they were prototyping this modular example, because the whole idea is, wouldn't it be great to have these natural systems in your apartment, is that they set up this green wall in one of our conference rooms for over a year and a half. And there's going to be an incredible white paper that comes out in, I don't know whether it'll be Scientific American or whatever, but these plants give off what the easiest thing I say is a bio yogurt. And so imagine that you're not getting just fresh air and it's taking the PMs out, but you're also getting this diversity, this biodiversity in your living space. And so it's really exciting. So the fact that it's not based on using soil, and that inside this box, you have all the computers, all the watering. So it takes care of itself. Obviously, you got to fill it up every couple of weeks. But here you have a living system that is actually helping support, the air quality within your space. And so I want to say that, it's a challenging time right now, but there's so much opportunity. And I think, you're at a school that is very ingrained in a philosophy of means and methods. It's really leveraging that type of mentality, but reaching out and working with fabricators, having that feedback conversation, working with builders and understanding that, okay, this is the design, now you figure it out. No, let's figure it out together. And I think probably the most important, I already said how important culture is to the success of your practice. The press tends to look for the heroes, but I gotta tell you, to make this happen, it's a team effort. And so it's a really exciting time, and you can't go it alone. You really have to find those partners that you can really confide in, and you don't always get along. Actually, the person I have the most trouble with is my twin brother. But it's you have to have those hard conversations. You have to break a few glasses. But this is how you innovate. And on that, thank you for listening.